Okay, page 3 of our Chapter 4 review. All right, midpoint of BE makes BC the same as CE. They told us BAD, that angle, is congruent to angle EDA. And the vertical angles in the middle there can give us our second pair of angles. So the triangles are congruent by angle, angle, side. Okay, now in coordinate geometry, we haven't done a whole lot of those. So, but for coordinate geometry, if we get one, so there's, for side, 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 what you would do is calculate the length of each side. Okay. So yes, right here. So basically what you would do is if we were to get triangles on a graph set up this way, you would count across 6, count up and down 8 on the first triangle, same thing on the second triangle. Now, so far you have 2 pairs of corresponding sides congruent. The third side you would get from Pythagorean theorem. You would show 6 squared plus 8 squared equals 100. Square root of 100 is 10. So in both cases, that third side would be 10. So equal length sides gives us congruent sides. And there's 3 pairs there, so side, side, side. All right, now for hypotenuse lag, much more involved. First, you have to establish a right angle. On graph paper, we do that through slope. So what I have here is I just am creating an example that's on, say it's on a graph, right? So from B to C, I would count over 3 and down 1. That would be a slope of, I'll slow down here, negative 1/3. From B to A, you would count over 2, down 6. That would actually be a slope of 6 over 2. Rise is 6, run is 2, and technically it's moving up and to the right. Now that reduces to 3 over 1. What you're noticing here, hopefully, is that these slopes are negative reciprocals. Negative 1/3, positive 3 over 1. So those 2 sides will create a right angle. Slopes that are negative reciprocals are perpendicular sides. Perpendicular forms right angles. Now, it'll be the same thing in the second one, but you still have to show your work. Okay. There's really no new calculation. It's just got to be stated. Got to demonstrate what those slopes are. Repeat the process. Okay, now here's where you communicate your ideas. Okay, just line these up. Now we've got to talk about perpendicular. Why is AB perpendicular to BC? Why is DE perpendicular to EF? It's because their slopes are negative reciprocals. Okay, now we can say that angle B and angle E are right angles because perpendicular segments form right angles. And now we can say those triangles are right triangles. And I want to go back and make sure I state, yes, those are right triangles because they have a right angle. Okay, so this is a step that's kind of necessary. That right triangle bit is because I'm going to use hypotenuse lag. I really should establish that they're right triangles first. All right, now on graph paper, I mentioned how to calculate the length of the sides, but I'm going to actually show it here. All right, it's a lot of work, but it's something we're going to have to do. So I'm going to calculate one pair of legs, okay? So BC and EF, I'm going to show you have a length that's a square root of 10. You're going to see the math of the Pythagorean theorem calculation for that. Now A to C, it's really right 5 up 5. So you're going to see the Pythagorean theorem for that. The length is going to be square root of 50. And same thing with DF. Okay, so if these were on graph paper, you would be able to see it a little better. Okay, so the only way to show congruent sides on graph paper is to show the lengths are equal. So we just showed BC has a length of 10. Now EF has a length of square root of 10. All right, so now I'm going to calculate side lengths AC and DF. Okay, so The change in x is 5, the change in y is 5. So Pythagorean theorem is being demonstrated here. The length of AC is square root of 50. Now the length of DF, it's identical numbers, but for a proof, we really should just go through the process, show the work properly, so there can be no argument. Okay, so why are those congruent? Because they have the same length. Now, we can establish the triangles are congruent by hypotenuse lag. Okay, so one thing on number 9 that we have to show, and this was the first thing we did in the chapter, was we have to assume, they have to tell us that the triangles are congruent, so let's assume they are. For us to create a mapping of one or the other, they have to be congruent if we want to use rigid motion transformations. Okay, so the first thing I check is orientation. That's going to decide if we need a line reflection to match the orientation, or if that's going to be skipped. Now in A and B, it's going to be skipped. Okay, the orientation for both of these is preserved. They're both clockwise. Same thing with B. Okay, so then what I do is I always translate to match one pair of corresponding points. So A to D. I'm always going to do that. I'm going to translate so that A maps to D. B's not going to map to E all the time right away. We're going to have to finish that in the second step. So I try to sketch it approximately where I think it's going to land. It doesn't have to be perfect. It's just got to be a decent attempt. All right, to finish this mapping, we have to rotate centered at D so we don't lose that matchup, so that B prime lands on E. Now we should mention center and angle. Okay. All right, so for B, I'm going to take it over to the scrap paper over here. Now I checked orientation first on this. They're both clockwise. All right, D, E, F, A, B, C, they're clockwise. So we're going to translate, okay, to map A to D, right there. Okay, that's approximately where I think it's going to land. And now we're going to rotate so that B lands on E. But we've got to center it at D. Make sure we mention center and say angle in there. Okay, back to C. Now orientation was not preserved, so I do have to line reflect. I always just go over one of the sides to make it easier. It doesn't matter which one. So I'm estimating where C prime would land. Okay, I'm trying to shoot perpendicular through AB and the same distance away to find C prime. Okay, and then I'm going to just, now that orientation is matched between my pre-image and image, I'm now going to translate and then rotate again to finish. Okay. So I'm attempting to estimate where a translation would take us. Okay. Now the rotation looks a little strange on this one, right? B has to go all the way around to E though. Obviously C would go to F. Centered at D again. And that's it for page 4. Or I'm sorry, page 3 of chapter review 4.